Hi everyone. Today I am going to discuss A levels maths paper 43, means paper 4 variant 3, mechanics paper, October November 2019. So let's start. Question number 1. A crate of mass 500 kg is being pulled along a rough horizontal ground by a horizontal rope attached a winch to a winch. The winch produces a constant pulling force of 2500 newtons and the crate is moving at a constant speed. Find the coefficient of friction between the crate and the ground. Okay. For this, first of all, we'll draw the diagram, vector diagram, which will help a lot in the solution of the question. Let's suppose this is the horizontal ground. This is the crate. This is the pulling force, which is 2500 newtons, and the weight of the crate is acting downwards, which is 5000 newtons, because the mass is 500 kg, so mg weight is 5000. Its normal reaction force R is directly upwards. Now, since the force is constant, so that's why the forward force is equal to the backward resistance force, because the crate is moving with constant speed. So that's why there is no resultant force. It means the force of friction is also 2500 newtons, because there is no resultant force. So this is the vector diagram of the question. Now, we know that frictional force is actually equal to mu r, Fc is equal to mu r. So the frictional force is also 2500 newtons. So by putting the values, mu we need to find, and r is actually equal to the 5000 newtons. So take 5000 on the other side, 2500 over 5000 is equal to mu, or mu is equal to 1 by 2, which is 0.5. This is the answer of question number 1. Question number 2. A train of mass 150,000 kg ascends a straight slope inclined at alpha to the horizontal with a constant driving force of 16,000 newtons. At a point A on the slope, the speed of the train is 45. Point B on the slope is 500 meters beyond A. At B, the speed of the train is 42 meters per second. There is a resistance force acting on the train, and the train does 4 multiplied 10 raised power 6 joules of work against the resistance force between A and B. Find the value of alpha. Okay. For this, again, we'll make a vector diagram which will help us in the solution of this question. So this is the slope and this is angle alpha. Okay, now let's suppose this is point A and this is point B. At point A, the velocity is 45 meters per second. At B, the velocity is 42 meters per second. Okay. Now, let's suppose this is the train. The train is applying 16,000 Newton force upwards. Okay, and the weight of the train is acting directly downwards, which is actually 15 and 50 newtons, because a mass is 150,000, so mass multiplied 10 will be the weight. This is the horizontal component of the weight, so this will also be alpha. This will be 1, 5, 1, 2, 3, 4, 5 cos alpha, and this is the vertical component of the weight, 1, 5, 1, 2, 3, 4, 5 sine alpha. Okay, there is a normal reaction which is directly upwards r. So this is our vector diagram of the question. Now, the distance of this slope is actually 500 meters. This is also you should keep in mind. Okay, now at point A, there are two quantities in the train. Number one is the kinetic energy, and number two, the train started doing work from A to B, because the train is pulling, exerting force, engine is exerting force of 16,000 newtons for the distance of 500 meters. So, it will be like kinetic energy at A plus work done at A is equal to the kinetic energy at B, because these two things will be converting to the kinetic energy. Number one, in kinetic energy at B, plus when the train reaches B, the train got some height, this height from the ground. So I'll find out later on what is the value of height. This is the height of the train. So the train will get some potential energy at B, and the third thing, work done against friction. So these three things will be equal to these two things in this whole question. So what is kinetic energy at A? That is 1 by 2, mass is 1540, and velocity at A is 45 square, plus what is the work done? F into D. The force is 16,000 and the distance is 500. So 16,000 into 500. equals kinetic energy at B. So what is the kinetic energy at B? The velocity is 42, so 1 by 2 into 1540 into 42 square plus potential energy at B. Potential energy at B is mgh. Mass is 150,000. G is 10 and h. We need to find h first. So let's suppose this is C. From triangle ABC, we know this is perpendicular and this is hypotenuse, and the 500 is the hypotenuse, so we can relate them by the sine. So we know that sine alpha is perpendicular hypotenuse, so it means h over 500. So h will be 500 sine alpha. So we'll put this value of h here, mgh, which is 500 sine alpha plus the work done against the friction. What is the work done against the friction? This is 4 multiplied 10 power 6 joules. So it means 4 and 6 zeros. This is the work done against the friction. So this is our complete equation of the question. Okay, after solving them by the calculator, I'll get this is 15187500. This is kinetic energy at A, plus this will be 8 1 2 3 4 5 6. This is the work done started from A. Now the kinetic energy at B will be 1 3 2 3 5 zeros. This is the kinetic energy at B. What will be the potential energy? 7 5 1 2 3 4 5 6 7 zeros sine alpha plus 4 1 2 3 4 5 6 zeros. Now I will take this and this thing to the left side of the equation, so this will becomes 15187500 plus 8 1 2 3 4 5 6 zeros minus 1 3 2 3 1 2 3 4 5 zeros minus 4 1 2 3 4 5 6 zeros is equal to 7 5 2 3 4 5 6 7 zeros into sine alpha. Now when I'll solve this whole equation with the calculator, I'll get 2 3 5 7 5 triple 0 is equal to 7 5 1 2 3 4 5 6 7 zeros sine alpha. So take this quantity on the other side. It will be like 2 3 5 7 5000 over 7 5 1 2 3 4 5 6 7 into sine alpha. So this will give sine alpha is equal to 0.0314. So alpha will be sine inverse 0.0314, which is alpha is equal to 1.80 degrees. This is the value of alpha, which is our answer. Question number 3. Three coplanar forces of magnitude 50 Newton, 60 Newton and 100 Newton act at a point. The resultant of the forces has magnitude R Newton. We can see the R. This is 100 Newton, this is 60 Newton, this is 50 Newton. The direction of these forces are shown in the diagram. Find the value of R and alpha. So for this question, I need to make the diagram again at a bigger scale so that I can resolve the forces into their components. So for example, this is the point. Okay, first of all, this is force of 50 newtons and the angle is 20 degrees. It means this is 50 cos 20 degrees, because this is the horizontal component of 50 Newton, and this is 50 sine 20 degrees, because this is the vertical component of the force. There is another force of this 60 Newton force, which is acting in the same direction as the 50 cos 20. The third force is 100 newtons. So if we see, the angle of 30 degrees is with y-axis, so that's why I'll resolve it like this. This is the horizontal component of 100 Newton, which is 100 cos 30 degrees, and this is the vertical component, which is 100 sine 30 degrees. Okay, and this is the resultant force R. So this is alpha. It means this will be the horizontal component of resultant, which is R cos alpha, and this is the vertical component of R, which is R sine alpha. So this is the vector diagram of this whole question. Now, first of all, because these are the coplanar forces, so first of all we'll find the sum of all the horizontal components of the forces, that is sigma fx. So all the right hand side forces will be positive and all the left hand side forces will be negative. This is what we always do. So what are the right side horizontal forces? This is 100 cos 30. So for the moment we'll forget this R, will not consider this R resultant force when we'll do the horizontal sum of horizontal forces. I'll explain later. So there is one force, this is 100 cos 30, 100 cos 30, this is to the right side, minus 50 cos 20 degrees. Sorry, this is 100 sine, this is the horizontal component, this is actually vertical component. So this is horizontal, this is 100 sine 30 minus 50 cos 20 minus 60. So this is the sum of horizontal forces. So by solving with the calculator, I will get sigma fx is equal to minus 56.98 Newton. This is the sum of all the horizontal forces. This negative sign is showing that this force is on the left side. Okay, if we see that the resultant force vertical component is actually along the horizontal, so that's why the sigma fx means the sum of all the forces should be equal to the resultant horizontal component, because R is the resultant force. So since sigma fx is equal to R sin alpha, because R sin alpha is the horizontal component of resultant force, and all the horizontal forces sum must be equal to the R sin alpha. That's why I'll put this value here. So it will be R sin alpha is equal to minus 56.98 newtons. This is equation number 1. In the same way, now I'll find sigma fy, means the sum of all the vertical components of the forces. So what are the vertical components? There are two vertical components. We'll forget this resultant force for the moment. So after this, there are two vertical components. One is 100 cos 30 and one is 50 sin 20. So all the upward forces will considered to be positive, and all the downward forces are considered to be negative. So this will be 50 sin 20, 50 sin 20 minus, because this is downward force, minus 100 cos 30. So minus 100 cos 30. So by the calculator it will be like minus 69.5 newtons sigma fy. But sigma fy, because this is the sum of all the vertical components, so this should be equal to the vertical component of resultant, because R is the resultant. So vertical component of resultant is R cos alpha. So the sum of all the vertical forces must be equal to R cos alpha. So sigma fy should be equal to R cos alpha. So I'll put the value here. So I will get R cos alpha is equal to minus 69.5 newtons. This is equation number 2. Now, for the resultant force, we know that R is equal to R cos alpha square plus R sin alpha square, because if you see the figure, R is the hypotenuse. So by the Pythagoras theorem, base square plus perpendicular square root is equal to R. That's why base square plus perpendicular square root is equal to R. So by putting the values, R cos alpha is minus 69 56.5 square and r sine alpha is minus 56.98 square, which is equal to the 8076.91, and which is equal to r is equal to 89.87, which is almost equal to 89.9 newtons. This is the value of resultant force. Now for alpha, we know that we'll divide 1 by 2, means r sine alpha over r cos alpha is equal to minus 56.98 over 69.5 minus. So this minus cancelled, this r is cancelled with this, so we got tan alpha, because sine alpha over cos alpha is called tan alpha. By dividing this by the calculator, I'll get so right now I'll write as it is, 56.98 over 69.5. so take tan on the other side, it will be alpha is equal to tan inverse 56.98 over 69.5, which is equal to 39.3 degrees. So this is our answer, alpha. Question number 4. A car travels along a straight road with constant acceleration. It passes through points P, Q, R and S. The time taken for the car to travel from P to Q, Q to R and R to S are each equal to 10 seconds. The distance QR is 1.5 times the distance of PQ. At point Q, the speed of the car is 20 meters per second. Show that the acceleration of the car is 0.8. Okay. For this, we need to draw a little diagram here. Let's suppose this is the straight road. Okay. This is point P. This is Q. This is R. And this is S. As you can see, the distance is increasing because the car is accelerating. Okay. Here we got some quantities. For example, the time here is 10 seconds. Here the time is also 10 seconds. Here the time is also 10 seconds. The velocity at Q means this is the final velocity, which is V is equal to 20 meters per second. This is the final velocity at Q. It means the initial velocity at Q for the second distance will also be the same. U is 20 meters per second. So because the final velocity of the first journey is equal to the initial velocity of the second journey. Okay, we also got let's suppose the distance of PQ S is X. The distance of QR, which is the 1.5 times of the distance of PQ, means 1.5x. So these are the things we got. Acceleration is same, so acceleration is same throughout the journey. Okay, This is our diagram. Now for PQ, we got V, T, A. So we need U. For U, we'll use the first equation of motion. V is equal to U plus AT. So this is 20 is equal to U plus A into 10. So 20 is equal to U plus 10A, or U is equal to 20 minus 10A. This is the initial speed U for the PQ. Now we have S, T, A and U and V. So we'll use the second equation from second equation of motion, which is S is equal to UT plus half AT square. So S is X, put the values. X is equal to U is 20 minus 10A, 20 minus 10A, time is 10 seconds into 10 plus 1 by 2 into A into 10 square, because A is A. So this will become X is equal to 200, I'll multiply 10 inside, minus 100A plus 1 by 2 into A into 100. 10 square is 100. So this will be cancelled with 50. So I'll get X is equal to 200 minus 100A plus 50A. So X is equal to 200, and minus 100A plus 50A means minus 50A. This is equation number 1. Okay. Now I'll take start from the upward again. For the second journey, for QR, so I got S, T, U and A. So I will use directly the second equation of motion. Second equation of motion, which is S is equal to UT plus 1 by 2 AT square. So S is 1.5x, that is 1.5x is equal to U. Here the U is 20, time is 10, 1 by 2 into A into 10 square. So this will become 1.5x is equal to 200 plus 1 by 2 into A into 100. This will be cancelled with 50. So 1.5x is equal to 200 plus 50A. Now I will put this value of x from 1 here. So from equation 1, I'll put the value of x, put value of x. So this will become 1.5 into x is 200 minus 50A. 200 minus 50A is equal to 200 plus 50A. Now multiply with 1.5 inside. So this will be 300 minus 75A is equal to 200 plus 50A. So take 75 on the right side and 200 on the left. So this will become 300 minus 200 is equal to 75A plus 50A, and this will become 100 is equal to 125A, or 100 over 125 is equal to A. So A will be equal to 0.8 meters per second square. This is the value of acceleration which is shown, because we need to show that the acceleration is 0.8. Part 2. Find the distance qs and hence find the average speed of the car between q and s. So if you see the diagram, previous diagram, so qs is actually the sum of two parts of the journeys from q till s. So we'll use this whole part of the journey as a single, and we'll find the distance of qs. So some things which you should keep in mind: at q the initial speed is 20. Now the total time will be 20 seconds, because there are two parts of the journey. So 20 seconds. We got a as well, which is 0.8 in this part. So we'll use all these quantities to find the values of qs. So for qs, this u is 20 meters per second. We got u. We also got time is equal to 20 seconds, because there are two parts of the journey. We also got a, which is 0.8 meters per second square, and we need to find s. So now if you see closely, we can easily use the second equation of motion, which is s is equal to ut plus 1 by 2 at square for qs. So now put the values. S is equal to u is 20, time is again 20, plus 1 by 2, a is 0.8 and t is 20 square. So this will be 400 plus 1 by 2 into 0.8 into 400. Okay, so this will be cancelled with 200. So this will become s is equal to 400 plus 0.8 multiply 200 is 160. So the s is 560 meters. This is the first answer. We also need to find the average speed of the car. So everyone knows average speed means V average means total distance covered divided by total time taken. So the total distance from Q to S is 560 meters. This is the total time is 20 seconds. So this will become 28. So 28 meters per second. This is the average speed of the car from Q to S. This is the answer. So that is the first part of the video. I'll explain the rest of the questions in the second video. So see you in the second video. Thank you for watching.